Hi students, today we are back with questions from the chapter Light which has appeared in the CISE specimen paper for the subject physics. Okay, this are the questions from the chapter Light. So let's move on to the question. In the first question, it is given that the given lens is made of two materials having refractive indices mu1 and mu2. It is asked that after refraction from the light from the distant object, how many images will be seen? Okay, since the refractive indices of upper and lower half of the lenses are different, after refraction, the object will clearly form two different images because both the upper and the lower halves will refract the coming or the incident ray to different extent. Okay, so obviously we can form two different images after refraction. Okay, so moving on to the next question. The diagram shows a fish in a tank and its image seen on the surface of the water. Name the phenomenon responsible for this image. It is actually the phenomenon called total internal refraction. Okay, it is the phenomenon of total internal refraction. So while learning the phenomenon of total internal reflection, you should recall the basic essential conditions for the phenomenon of total internal reflection, which are basically the light ray must be incident from the denser medium to the rarer medium. Okay, and moreover, the angle of incidence must be greater than the critical angle for the pair of media. Okay, the angle of incidence must be greater than the critical angle for the pair of media, and the light must be traveling from a denser medium, optically denser medium, to a optically rarer medium. Okay, so what basically the total internal reflection is when a light falls on a surface separating the two media from a optically denser medium to an optically rarer medium at an angle of incidence greater than the critical angle. Okay, this angle of incidence must be greater than the critical angle for the pair of media. Then the light ray rebounces back to the same medium at the same angle. Okay, this phenomenon is called the total internal reflection. So the two conditions are the light ray must be traveling from a denser medium to a rarer medium. Moreover, the angle of incidence must be greater than the critical angle. Okay, angle of incidence must be greater than critical angle. The next question. It shows a double convex lens having refractive index mu1. So this is a lens having refractive index mu1 and it is placed in a liquid having refractive index mu3 as in figure A, and it is dipped in a liquid having refractive index mu2 as in figure B. Okay, it is given that this mu1 is greater than mu3. Okay, it is given that mu1 is greater than mu3 and also mu2 is greater than mu1. Okay, so in the first figure, a lens of higher refractive index is being submerged in a liquid having lower refractive index. Okay, so in such a case, the lens tend to show the phenomenon or the process of convergence. Okay, so it converges the beam of light which is entering. So the first answer would be the light ray will converge. Okay, so the basic concept which you should be aware of is that when a lens of refractive index mu is dipped in a liquid having lesser refractive index compared to that of the material of the lens, it shows a converging action. Okay, whereas in figure B, it is observed that a lens of refractive index mu1 is dipped inside a liquid of refractive index mu2 and the refractive index of mu2 and the refractive index mu2 is greater than mu1. Okay, here the lens is dipped in a liquid having refractive index greater than that of the material of the lens, isn't it? So in such a case, the lens will show diverging action. Okay, so in the figure B, the ray of light after refraction tends to diverge, and in figure A, the ray of light tends to converge. Okay, so the answer for the first one is converge and the second one is diverges. Okay, and to the next question, it shows a mixture of blue, green and red light which is falling on a lens. It is asked whether after refraction from the lens, whether the light, all the three colors of light passes to the same point. Okay, we already know that it is no, because the speed of light is different for different colors in the lens or in the case of a prism. Okay, so it deviates or rather disperses the light through different extent. So all of these colors will be at different points and they do not lie at the same point on the principal axis after refraction. Okay, because the lens refract the three colors red, blue and green, which is of different speed and different wavelength through different extent. Okay, so after refraction from the lens, all the three colors will be on different points on the principal axis. Okay, so that's the answer. So moving on to the next question, it is given that a scientist lowers a metallic ruler vertically into a transparent oil tank. The ruler touches an object placed at the bottom of a tank and gets wet up to 25 centimeter mark, which means that the ruler which he has dipped it inside the beaker gets wetted up to 25 centimeter mark. Okay, which implies that the real depth of oil inside the beaker is 25 centimeter. Okay, if the refractive index of the glycerin is 1.25, up to which mark will ruler get wet if the scientist lower it up to image of the object? So we need to find, it is given that the real depth is 25 centimeter and the refractive index of the glycerin is 1.25. So we need to find the apparent position, okay, or rather the apparent depth inside the beaker. Okay, so let's try solving it. We already know that refractive index mu is equal to real depth divided by apparent depth. Okay, we know that refractive index is real depth by apparent depth. So it is given that the refractive index is 1.25. 1.25 is equal to the real depth is 25 divided by apparent depth. Okay, so in order to calculate the apparent depth, we need to divide 25 by 1.25. Okay, which is equal to 20 centimeter. Okay, 20 centimeter. So the apparent depth is 20 centimeter while the real depth of the liquid inside the beaker is 25 centimeter. Okay. Moving on, how will the length in part A change if another liquid of refractive index greater than 1.25 is used? Okay, so it's been asked, we know that refractive index is equal to real depth by apparent depth. Okay, so it is asked how will the apparent depth change if the refractive index of the liquid is greater than 1.25. Okay, greater than 1.25. Now we can observe that there is an inverse relation between mu and apparent depth. Okay, mu is inversely proportional to the apparent depth of the object. So for the refractive index to be of a higher value, it is evident that the apparent depth must be of a lower value. So in the part 2, when the liquid is replaced by another liquid having refractive index greater than 1.25, the answer would be surely less than 20 centimeter, which was our answer in part 1. Okay, so in the section B, the question B, the answer is it would be less than 20. Okay, yes, it would change because we know that the refractive index mu is inversely proportional to the apparent depth. Okay, for the refractive index to be of a higher value, it is evident that the apparent depth must be of a shorter value. So it is clear that on increasing the refractive index of a liquid, the answer which we have got in the part A must decrease. So the answer is the refractive for the refractive index to increase, the apparent depth must gradually decrease. Okay.